And now we'll hear something about from Alex about the 30-day map challenge.
Hi.
Hi.
Is it working? Can you hear me?
Yeah, great. Okay, so same as before, just if you have any questions, just post them in the chat. And well, yeah, stage is yours.
Thanks, Daniel. And also thanks to Michael for the great introduction on geospatial and R. This makes it easy for me to build on this now and talk a little bit about interactive map visualizations with R. And I'll do that with the 30-day map challenge. First about myself, my name's Alexandra Kapp, and I've been with Correlate for, I don't know, a little more than 2 years, 2 or 3 years now, especially with the local chapter Berlin. Other than that, I work as a data analyst for the Mobility Institute Berlin since the beginning of this year, where I also work a lot with geospatial data and maps. So yeah, this is also why I got a lot deeper into that this year. Today I want to talk about the 30-day map challenge. So first of all, what is that? It's kind of a challenge that someone started on Twitter, where you publish a map each day with the following themes, no restrictions on tools or data, but all maps should be made by you. I think this has been there last year for the first time, and again this year. So yeah, it's right in the middle of the challenge right now, as it's the 7th of November at the moment. So today's theme is green. And the idea is that every day there is a theme, and that you can create a map for that theme and post your result on Twitter. So the idea behind that is really just for you to have some reason to play around with the map data and post it on Twitter. There's nothing to win or nothing basically coming out in the end, just kind of a fun hashtag to follow and to see what people come up with. The different topics were posted, I think, at the 1st of October. So you could also prepare the maps beforehand, which is also what I did on a weekend where I had a little bit of time. And now I'm just kind of posting them day by day. And yeah, this is what I want to share with you today. So I didn't make all 30 maps for all 30 days, but I think about 15 days or so. Maybe, I don't know, if I have the time, I'll also make some more. And today I want to share 10 of those maps with you. And they're mostly made with R and interactive maps with R. The ones I'll share today, they're all made with R. And there are basically 2 main frameworks that you can use. So Michael already talked about MapView, that's a great package. And MapView under the hood is actually using either leaflet or MapDeck. I think you can choose which one you want to use. And yeah, those are basically the 2 frameworks that you can use for interactive maps, which I also used. And for those of you who are not familiar with those, a quick introduction: what is leaflet and what is MapDeck? So leaflet is basically the leading open source JavaScript library that has been around for about 10 years. And usually when you see a map on a website, it's usually made with leaflet. So if you have a website of an organization which has a little map where you can see this is where our office is, that's usually leaflet. And then there is Deck.gl, which has only been around for around 4 years. And this is especially great for large data sets and also for 3D visualizations, like you can see here on the picture. And of course, for leaflet, there is an R package, but more recent, there's also an R package for Deck.gl, which is called MapDeck. And yeah, now I want to go ahead and show you my maps that I made for the challenge. My goal was especially to try out different possibilities of creating those interactive maps, and yeah, to kind of see how far can you go with R to create different maps. What are the possibilities? And that is mainly what I want to also show you today. So just give a pretty fast run through. It's about, I guess, 2 minutes for each map. to just give a quick run through what is there actually possible if I want to do this plotting with maps with R, and just to kind of have heard about the different packages that are out there, because usually you just need to know the right R package that you need for your purposes. And yeah, I will show short code snippets, but you don't need to understand all of the code. It's mostly just to show you that it's actually super easy for all the different days and maps that I made. It's just like really a short amount of code that I used, just to show you it's yeah, easy to implement. And if you're interested in reproducing any of that or taking ideas out of that, I also have all the code snippets online on GitHub. So let's get started with the first map. Also, I won't run through the days in the right numbering. So if I jump from day 1 to day 8, you didn't miss anything. I just ordered them in a way that makes a little bit more sense for this presentation. But we still start with day 1, which is points. And what I did is I took the amount of cars that there are in Berlin, Friedrichshain, Kreuzberg, which are about 80,000 cars. And I plotted 1 point for each car onto the streets of Friedrichshain-Kreuzberg. And you can see that it's actually pretty crowded on the streets. It's not perfectly plotted, but actually after I did that map and then went around on the streets and realized how many cars they're actually parking, it kind of felt accurate how many cars there are. So on a technical level, the idea behind this map was to play around a little bit with some of the basic functionalities of the SF package that Michael just showed us. So this is one example where you could use that crop, not the right word as we just learned, it's rather the intersection of one polygon, which would be the streets of Berlin, and then intersecting those with the Friedrichshain-Kreuzberg outline, so to cut all the streets in Berlin just down to the streets of Friedrichshain-Kreuzberg. And then the more interesting part here, just sampling different points within a polygon. So now we have that polygon of all the streets in Friedrichshain-Kreuzberg, and with the simple function of stsample, we can just say, okay, we want to have 80,808 points within that polygon. And yeah, then you just have your cars and you can plot them, and you're done. The second map is for day 8, which had the topic of yellow. So what you can see here is the hours of sunshine in 2019 in Germany. And yeah, when you hear people say in Hamburg it's always raining and no sun, but in the south or maybe in Berlin there's more sun, they might be right. So this is a data set from the Deutsche Wetterdienst, which you can download as a raster data set. And we just learned from Michael what raster data is. And yeah, you can not only plot the vector data, but also the raster data easily with leaflet. And then you have your little pop-up here where you can see, okay, in Berlin there's about 2 hours of sunshine in a year, or had been in the year of 2019. And again, this is super easy to implement. You just basically start your leaflet map with the command leaflet. You add a base map so that you can see a map underneath. And you just then need one command from the leaflet package, add raster image, where you insert your raster data. And then you have another function from the leaf am package, add image query, which gives you the little pop-ups. And then again, within just 4 lines, you have your raster plotted nicely on that map. Day 3 is on polygons. So my idea here was, as I'm personally a climber and also boulderer, to kind of see how many boulder gyms are there, but then which area is the closest to each boulder gym. So basically which boulder gym, if everyone would go to the closest one, according to Beeline, which area would be covered by this boulder gym. And we can see the ones more in the center, the Boulder Club, for example, which just has a quite small area, but also very dense area. And then another one is the Ostblock, which would cover, if everyone would go to the closest gym, would cover the entire east. Yeah, my idea here was to play around with the so-called voronoi diagram or map, where you just insert this point data, and then you get those polygons as a result. And again, this is also fairly easy with the right package. So here I use the Dismal package, where you have the function voronoi, and you just insert your point data, and then you can get those polygons, which you can then plot on the map. Day 14, climate change. Here you can see an area which is 121,000 kilometers square meters large. And this is how much rainforest had been destroyed in 2019. And what I wanted to try out here is to make editable, or in this case, movable objects on a map. So with basically activating this, you can move around the polygon and basically check, okay, how large is this area actually? For example, you can see, okay, it's basically, I don't know, the entire area of Denmark that is covered, or yeah, just move it somewhere else. And yeah, also here I use the leafpm package with a simple function add pm toolbar, which allows you to not only move the vectors, but you could also draw or cut or edit polygons onto your map that you've plotted. Day 9, monochromes. So monochrome is basically just a single colored map, or like a grayscale map. And the topic of this map is the lifelines of Berlin. And here I wanted to find out what are the major streets in Berlin without knowing anything about the roads themselves. And what I did is I just took 500 random points within Berlin as start points, and then took another 500 random points as endpoints, and routed them. And this is basically the results. Which of the streets are mostly used when you run those routings. And you can see here the very thick line of the Stadtautobahn, so the city autobahn, and also the other major streets, because yeah, if you drive a long way, you usually would not go through like the minor streets, but you would use the main streets. And there's also a super nice package, which I can really recommend for doing stuff with with routing, but also with public transport, which is called stplanar. And so again, sampled with the stsample functions, random points, and then I used the stplanar route function, which gives me the routes from the start point to the end point as a line, as an line object. And then with the overline function, it basically counts how often which segment of the street is being used. And then if you count that, you can use this count to make this line thicker and plot this thicker, so that you get this this view that I just showed before. Day 20, population. This takes a second to load because this is. So you can also use map deck and leaflet both super nicely with Shiny, if you're familiar with the Shiny framework. And what you can see here is people that already lived in Berlin moving. So for example, I lived in Friedrichshain-Kreuzberg, and then I moved to Köpenick or something. Then I would be counted as someone moving to Köpenick. And what you can see here is that the center, Mitte and Friedrichshain-Kreuzberg, there are people moving away, so it's a negative number, while the outer skirts of the cities have people coming in. So once you live in Berlin, you rather move to the outer skirts. You usually don't come and move to Marzahn-Hellersdorf and then move back into the center. And now you can click on a single district. So for example, on Marzahn-Hellersdorf, and see where the people are actually coming from. So you see that most people who move to Marzahn-Hellersdorf come from the neighboring district Lichterfelde. Not Lichterfelde, sorry, Lichtenberg. Or if you click on Mitte, you see most people are coming from the neighboring districts here. And yeah, you can also go back to the overview. So the interesting thing that I wanted to try out here is to A, combine it with the Shiny app, but B, mostly make the map interactive in a way that I can click on a part of the map and then yeah, do show some different data and basically have a reaction on my click on the map. And yeah, if you're familiar with Shiny, you probably know those observe events. So also if you just click a button or, I don't know, have any interaction with your app in the Shiny app, you usually work with observe events, and which is really nice with the leaflet map, but also with the map deck maps, that you can have an easy observe event. So if your name of your map is map, then you can just do map shape click and then get the coordinates of the point where you clicked at. Day 2, lines. What I'm plotting here is the air traffic between all German airports, which is data from the EU Open Data Portal. And there you can see that the most air traffic is happening between Berlin and Düsseldorf, and Düsseldorf, Munich, Frankfurt, Berlin. And you can also click on a single city and only get the data here. And yeah, what you can see here, flow map blue, this is an own yeah, tool, I guess, which was developed by one guy, which is pretty cool, because you can easily map those origin destination flows, which is on the one hand possible entirely without R or any programming. It started out as just with Google Sheets, so you put your data into Google Sheets and then you get those maps, which is really nice. And pretty new this year is that it's also available as an R package. And yeah, that's just a really nice and easy way to map origin destination data. And yeah, get a nice visualization out of that. Day 10, I think second to last. Grid. This again takes a second to load. The idea here was, or that I asked myself a question, where within Berlin can you get what kind of food? So Italian food, Turkish food, German or Vietnamese. This is not evenly distributed over the city of Berlin. And here you can see, for example, Turkish food, so mostly also kebab. You can get in Neukölln, in Kreuzberg, also a little bit here in Wedding. And if you switch to Italian food, for example, you see that you mostly have it in Kantstraße, in Charlottenburg, and also in Mitte. Or Vietnamese food, you have more in Friedrichshain, but also in Prenzlauer Berg, a little bit in Kreuzberg. And what's also especially nice about this map is that you can zoom in and out, and the grids scale up and down according to the zooming. So this is basically two parts in here that I wanted to show. The first part is the data. So the data that is behind those restaurants is from OpenStreetMap. For those of you who don't know OpenStreetMap, it's kind of the open source alternative to Google. And there you have a huge resource of openly available geodata. So I don't know, streets, rivers, restaurants, stores. And there is an API for that where you can easily retrieve this kind of data. And this data is also accessible with a super cool R package, which is called OSM data. And there you can see it here. It's just, I don't know, there's 4 lines of code where you say, I want to have the data within Berlin and the feature of amenity, fast food and restaurants. And then within this one call, you already have the data and also the geodata, especially on all the restaurants that are listed within OpenStreetMap. And then once you have the data to make a map out of it, I here used MapDeck, and I only inserted the point data, so there's no pre-processing of making a grid or raster out of this yourself. You just insert the point data, and the point counts are automatically aggregated to this grid. So it's basically just calling MapDeck and then saying add screen grid and adding the point data, and then you already have this grid, which is yeah, pretty cool. Day 4, hexagons. This map shows all traffic accidents in Stuttgart. So the Unfallatlas Statistische Ämter offers a data set, a point data set on all accidents within Germany. And yeah, here you can see a map where those points are aggregated to hexagons. And yeah, you can also like change the tilt and the shift with shift. And there you can see where most of the accidents within Stuttgart are happening. And again, as with the grid data before, this is a function with the map, where this time we're not using a grid, but a hexagon. And there you also just have to insert the point data, and then this is automatically aggregated to this hexagons. And the last map, day 22, movement. And this shows all the U-Bahns at their actual time when they leave the station within Berlin. Here I only inserted a video because the map is rather big, and I think I also got stuck now. But yeah, the idea is that the lines are moving through Berlin. And again, this is made with MapDeck, and also basically just one line of code where you have to add trips and then your U-Bahn data, and then you're done. Then you're having the moving lines. A little bit trickier is to get the timestamps into the geodata of the U-Bahn, because that's a kind of pre-processing step you need beforehand. But it's also doable. And if you're more interested in that, yeah, you find infos on that in the internet, or yeah, have a look at my code there. And that has been my 10 maps. So thank you very much for your attention. Happy to have questions if you have any. And yeah, you can find this presentation here on my GitHub repository, as well as all the examples and code. I'm just uploading them yeah, every day in November now, with the coming days of the map challenge. And yeah, happy to hear questions.
Yeah, thank you very much, Alex. I think it's quite impressive. So how much or how many different plots there were, and how creative, actually. So if someone has a question, they can just post them in the chat again. I don't know, maybe just out of curiosity, did you have or had experience with all those plots, or did you, I don't know, read into them, or how did you come up with all the ideas?
So with the general geodata in R in the maps, especially with leaflet, I had experience before, also because I do that at my job. And I kind of wanted to use this challenge to do some stuff that I don't really get to doing at work. So like not doing the stuff I regularly do, but kind of trying out the fancy things you actually that I didn't need before for the actual work, but that I always find interesting to know a little bit more about, and just have a reason to kind of get to it. Yeah,
yeah, it's really cool. So there are no questions so far. Yeah, also like Thomas is saying, it's quite a good inspiration, or so I don't know, for creating own maps. So
nice. Yeah, that was the goal. So if that happened, then I'm happy.
Yeah.
All right. And if there are any questions, feel free to just contact me here or on Slack or wherever.
Okay, great.
Thank you.
Thank you.